Thank you for the introduction. Yes, so my name is Matti Laakso. I'm from the KONE Corporation Services and Solution R&D, situated in Finland, in Hyvinkää. And just slightly about my background. I've been working for KONE now 4 years, last 2 years of which I've been working as a condition monitoring expert. So I'm on the elevator side, basically in the maintenance development. So my core knowledge is about trying to apply predictive maintenance to elevators. But on the side, or actually more and more now lately, I've been focusing on getting everything connected, including also the escalator side. Something about KONE as a company. So most of you probably know what we do. It's elevators and escalators. KONE is one of the largest elevator companies in the world. So there's basically 3 big ones. It's KONE, Otis, and Schindler. Each one has roughly 1/3 of the market share in the new elevator business, new equipment business. But of course, then we also do maintenance, and I'll talk about that in a while. We move basically billions of people every day, so it's a really an important part of the modern society, the elevators and escalators, the workhorse moving people around in big cities. And now with the mega trend of people moving to big cities, they are becoming increasingly important. And we have over 450,000 customers, ranging from really like small customers. You can imagine a single apartment building with, I don't know, some tens of apartments, up to huge airports with potentially hundreds of equipment, elevators and escalators. So KONE is a traditional big company, starting with basically manufacturing elevators, and now we are trying to transform more towards service business side and being a more data-driven company. So like I mentioned, we of course, maintenance is an important thing of what we do. And we have now 1,200,000 elevators and escalators in the maintenance base. Not only KONE elevators, but a very important part of what we do is we also maintain old elevators and elevators made by our competitors. So it's basically we want to provide first-class service, first-class maintenance for all brands of elevators and escalators. So then the question is that why do we want to connect these 1 million plus equipment to the cloud? So we have not yet connected this many of them. So only like we are talking about maybe hundreds of thousands, 100,000 around now. But the aim is for this 1.2 million eventually. And when we started this journey roughly 4 years ago, the obvious first thing that came to mind was that, okay, predictive maintenance is something that we want to do. So improve the efficiency of our own operations, just maintain the elevators, do service when it's absolutely necessary. And then when we are on site, use data to find out more quickly where the problem is, so improve troubleshooting. And then also use data to tell our customers that, okay, these parts are now approaching their end of life, so giving us a potential for selling, for example, spare parts to the elevator. But then there's one drawback is that okay, predictive maintenance is pretty hard actually. So especially if you aim for all brands of elevators. We know our own equipment pretty well, but then for our competitors' equipment, it's more challenging. And then there's a lot of local legislation that tells us that we need to visit the elevator, for example, 4 times a year or 8 times a year or even more often. So in these cases, we don't get that much benefit from predictive maintenance because we're still forced to obey the local rules and visit the elevator quite often. So then what we thought about next was that, okay, what if we can also provide some extra customer value by connecting the equipment to the cloud? So what we are now aiming for, or what we are actually doing now, is we react faster to malfunctioning equipment. So we know already before the customer calls us that the elevator is stopped or the escalator is no more running. That's one thing. And Okay, the predictive maintenance part, it translates into improved availability, so that's something that we also provide for our customers, but that's not the only thing. Then when we connect our equipment to the cloud, we gain knowledge about how they are used. So how many starts per day, how many kilometers does an escalator run, or how many hours running time. For elevators, we know which floors they travel to, and all this information is potentially valuable to our customers. Then from the usage statistics, we also know that we are able to predict, let's say, that certain parts that have a finite lifetime, that when it's the time to replace some big part, and customers really value the information if they are able to budget their maintenance fees for 5 years in the future. So helping our customers in budgeting is also one thing, that we're able to provide insights into the future life of the elevator. And then the last but not least thing that we thought about was to give our customers transparency. So how is the equipment working? For example, safety equipment in elevators. If it breaks down and we are not able to prevent it, or we are not able to notice it beforehand, then if the elevator stops and you're there in the cabin, there's the alarm phone and there's the button you press, and the customer knows that it's working because it has been doing these test calls every day, and last one has been successful just yesterday or today. So it's giving transparency to our customers that it's safe to use the equipment. So this is the approach that we basically took when we started providing our latest 24/7 connected services to our customers. So this is something that is based on we launched this 3 years ago, and it's based on connecting the devices and then putting data to the cloud, analyzing that, and providing insights to our customers. And this is something that we've done in partnership with IBM. How it works is that like I said, we fit some kind of connectivity device to the equipment. For elevators, it can be a sensor box. If it's a third-party elevator, if it's our own elevator, then we can connect the controller through a gateway to the cloud. Also for the escalators, it's a similar thing. We constantly keep collecting data, sending it to the cloud, and then we give our maintenance technicians access to this data, so that when they are on the site doing some work on the elevator, they have access to all the relevant information. And then, like I said, we provide our customers some insights into how their equipment is used, what kind of costs can they prepare for in the future to keep it up to date, and possibly then modernize it after some tens of years when the elevator is reaching its end of life. Then talking about the future, of course, the cities are moving towards smart buildings and smart cities, and connected elevators and escalators are an important part of those. So we're talking about optimizing people movement inside big buildings, inside building complexes. So there's indoor navigation is part of it, access control, like we learned from the presentation by Gabor from HID. All this will be connected together, and we want to be part of that, and provide, let's say, means for elevator to come when you go to the front door, and I don't know, you do this movement and open the door, then also the elevator will come and take you to the correct floor. So this is all enabled by connecting the elevators to the cloud. Of course, here, like we learned from the previous presentation, we need to take care of cybersecurity. So when we are connecting stuff to the cloud, then that's something to keep in mind. And especially if we are controlling elevators from the cloud, then it's important to consider the cybersecurity, and that's of course an important part of what we do. But I'm not going to talk about that more in this presentation. It would deserve a presentation of its own entirely. So basically, to sum it up, connecting elevators and escalators to the cloud is an investment both for KONE as a company and also for the customer. So in the future, it will be an important part of smart buildings and cities. So then going towards from why to how we do it. Basically, if we start with the connectivity device that we put there in the elevator, we've been, we've been connecting our elevators actually since '95 because of at least in Europe and in the North America, because of the requirement to have this alarm phone there in the elevator. So we've used to connect the elevators with the analog phone line for already more than 10 years. But now for this latest generation of devices, we are only using cellular network. Basically, it's now available all over the world. We can use 2G, 3G, or 4G network depending on availability, and then we just use whatever is available there on the site. So since we have our equipment all over the world, in every continent basically, we use globally roaming SIM cards so that we don't need to worry about local network providers. But this translates then into restricted data volumes. You all know that roaming data is more expensive, and we want to limit the amount of data a little bit. Also, the network speed might be a little bit slower when we're roaming on foreign networks. And this means that it's not possible for us to send all the data that we gather from the elevator, or the escalator. Let's say we have a sensor which measures hundreds of data points per second. It's just not possible to send all the data to the cloud, except maybe for R&D purposes in special cases. But in general, we need to compress it a lot to be able to fit into our data quotas. And that's why it's extremely crucial for us to do this data processing in the edge, in the edge device there on top of the elevator or next to the escalator. So we produce from the sensor data or from some other data carefully selected aggregates that are somehow valuable, either for the customer or for our predictive maintenance purposes. And then since we do not have a whole lot of, let's say for the sensor data, we don't have a huge history of data, we are not entirely sure at first that what kind of aggregates produce the most value. So we need to have a rapid cycle, rapid capability of having a rapid development and deployment cycle to get stuff out there on the edge device. And that's something that we've been working on a lot for the last year or 2 years, so that how do we maximize the cycle speed in getting, basically starting from some aggregates, testing how they work, and then updating our assumption, maybe modifying the algorithms running there on the device slightly, and how do we keep this cycle running fast. That's something that is very crucial for our use case. So some example data that we sent from escalators, there's vibration statistics, noise levels, passenger counts, operating time, power consumption, environmental stuff like temperature, humidity, and so on. Then for elevator, we have door movement statistics, travel statistics, distances, times, and so on. Elevators and escalators are actually quite different. So elevator is moving every now and then, escalator is usually running continuously, but the same kind of tricks we need to use for both, that we cannot send all the data, we just send some. Some examples, I checked that in the Kista region we have around 100 elevators connected, no escalators at the moment. I checked there the elevators that are used the most, and I checked some basic statistics. There were like 700 rides per day for one of the most used elevators here, and then I checked if they are running smoothly, so it seemed that there was no problems in that particular unit that I checked. There were some warnings about the doors being open for more than 1 minute at a time, and I think that's because there are people standing between the doors. So that's pretty common case with the elevators that this happens. So our system is able to adapt to the regular behavior for individual units, and then not produce false alarms because someone stands in the middle of the doors and prevents them from closing. Right, so like I said, we've been connecting our elevators already for more than 10 years with the analog phone line. And actually already we started like more than 10 years ago, we started sending once per day some basic also statistics about how much the elevators are used and what kind of fault codes they produce, basically for our own elevators. And when we started this, we had this pretty traditional legacy architecture of having a data warehouse and having there well, first of all, we had the time-based data, so once per day, and we stored them in a data warehouse, and then run some batch jobs overnight. But now that we are starting to to promise our customers that we are able to react faster to problem cases and produce data all the time, real-time data. We've done this. I might call it a paradigm shift, but to transform from this time-based data to event-based data. So whenever something happens, we send the data to the cloud. One example is when the elevator makes a movement from one floor to another, we send the information to the cloud. And this also requires a lot of completely different architecture from the cloud side to handle the data. So instead of data warehouse, now we have a data lake. Instead of scheduled batch processing, we now do real-time stream processing. And our architecture looks a little bit like this. There's the devices or the equipment there on the left, sending data over the cellular network. Everything that we send from there goes to a message queue. Basically, we use Kafka as a backbone for our cloud architecture, and then all our cloud components are connected to this Kafka message hub and consume data from there. We have on one part we have the device management, basically the basic connectivity, software updates, and so on. In the IoT platform, there we also run our operative analytics, so the streaming analytics that continuously read the data coming from the devices. We also provide APIs to external systems, so basically our maintenance technicians, they get data to their mobile phones. Our ecosystem partners get data from our devices, and then of course our customers. But the customers are actually connected to a separate platform, so we have our customer relations in a separate platform. But anyway, it's also connected to the same message queue. And then important part here is the data platform. So all the data that we get is put into the data platform. Our data analysts do the data exploration there. They do the modeling there. And then based on their findings, we develop the operative analytics then to the IoT platform side. So that's roughly what it looks. One last but still very important thing is monitoring the whole thing. So of course it doesn't help us if we don't know that our systems are working nominally. So important part is to monitor and make sure that everything works as they should. So we are constantly monitoring that the devices that we've connected to the cloud stay connected. Actually, I've heard from various sources that typically from industrial internet type of or Internet of Things type of use cases, it's pretty often that around 20% of the devices are disconnected at any time. And that's something that of course there's network outages and so on, but this is something that needs to be constantly monitored to make sure that they stay connected like we've promised our customers that they will stay. We need to monitor that the data flows correctly, all the interfaces are working, see that there's the amount of bytes going through the message queues stay roughly the same all the time. We manage software updates, so basically the kind of software updates where we do security improvements. This is different from the updates that update the algorithms on the device that we do in a more automatic way. And then remote troubleshooting. So if there is a problem, we have the capability to, let's say, reboot the connectivity device remotely and follow up on that. And then if necessary, also the monitoring center will then contact either the front line so that they can actually send someone out there on the site and see if someone has forgotten to plug the power socket, for example, for our connectivity device, or if there's a bug in the software. That never happens to us, but well, maybe sometimes, but anyway, then if necessary, we escalate it they escalate it to R&D so that we can fix the bug at some point. So to wrap it up, the large volumes of data that we get from the elevators and escalators, it's not only for predictive maintenance purpose, but we also try to find some other value-adding services for our customers. Important thing is this edge processing to get the data volumes down because of our globally roaming SIM cards. And especially when the number of connected equipment grows large, this is more and more important. So right now, our aim is for this 1.2 million units. But actually, in the world, there are 12 million elevators and about 1 million escalators. So, of course, our vision is someday to connect all of them to the cloud. Let's see how long it takes, but that's at least the vision that we have. And yeah, last thing here is that the data platform or the whole cloud platform needs to be designed from the start for the kind of data that you are getting. So we get this streaming data. We need to consider that from the start to be able to handle it. So with this, I thank you for your attention, and wish you a nice evening and the rest of the day. Thank you.